Please join me in welcoming our opening keynote speaker, Bill Caplan.
Tommy, Brendan, Megumi, thank you for inviting me to speak today. It's an honor to take part in this 7th annual symposium on climate change, especially here in the state of California. California was the first state to initiate embodied carbon policy and legislation, the Buy Clean California Act of 2017. I'd like to give a special shout out to AIA Los Angeles for promoting climate action at the chapter level. I'm from New York City. We have a climate problem too, though we are a bit too relaxed about implementing low carbon construction policies. When my associates and I first traveled to California for the space shuttle and various defense programs many years ago, the phrase embodied carbon was not even part of the English lexicon. Yet here we are today to discuss its pivotal role in sustainable design, its pivotal role in global warming. Embodied carbon and embodied emissions might be the most poorly named concepts in the global warming vocabulary. There's nothing embodied about embodied emissions. By the time we refer to them, they've already been released. They do not exist in the material or the product in question. This beautiful sky is what embodied emissions look like. Residing in the atmosphere is atmospheric carbon, not visible to the eye. They will remain there for hundreds of years. But they are there, multiplying the greenhouse gas effect. Water vapor is also a greenhouse gas. Most people don't know that. Water vapor and stratiform clouds contribute nearly 3/4 of the heat re-radiation, 3/4 of the greenhouse effect. Carbon dioxide is just 20% of the greenhouse gas mix. Though only 20% of the mix, carbon dioxide's greenhouse effect controls 80% of the impact. Heat re-radiation from atmospheric CO2 increases air temperature, which in turn influences the air's moisture content. But unlike water vapor, CO2 neither condenses nor precipitates from the atmosphere. It stays there, re-radiating the heat and enabling higher levels of water vapor, which do so as well. This nebulous thing called embodied carbon is one of the few warming accelerants that we can minimize within this decade, something that everyone in this room can do. So what are embodied emissions? Well, that depends on your perspective. To some, it's manufacturing emissions, the emissions associated with producing a product. That means from raw materials mining, through production and packaging, and everything in between, from cradle to the shipping dock. To others, it includes transportation to the construction site, or maybe installation, or maintenance, or repair, or refurbishment, or disassembly and disposal, or preparation for eventual reuse. Is embodied carbon important? The Inflation Reduction Act thinks so. It put $4.5 billion on the table for low-carbon construction materials. The Buy Clean California Act and the Federal Buy Clean Initiative think so as well, perhaps because embodied emissions are immediate and unrecoverable. With 2030 targets merely 5.5 years away and a climate crisis brewing, minimizing emissions up front is crucial to the 1.5 degree target. Even though the AEC industry has worked diligently to obtain energy efficiencies, to employ energy modeling, electrification, and energy decarbonization, and to design more net zero buildings, we need to take stock of what we refer to as sustainable design, stock of its veracity regarding emissions, stock of reality. Building designs come to fruition within the architectural professions. So how are we doing? Are we minimizing greenhouse gas emissions in a timely manner? Does our progress reflect building design? Or is it coming from equipment and appliance efficiencies? Or is it primarily from energy decarbonization? Is our current approach to sustainable design enough to thwart global warming? I've spent more than a decade investigating the built environment's impact on our surroundings, the last 6 years exclusively on embodied carbon's role in global warming. So much time that my wife, an urban planner in New York City, who is here today, somewhere out there, forbade me to mention embodied carbon or even EPDs during mealtimes. Truth be told, preferably not at all. So I'm sorry, Paula. Okay. But today, they are worth 6 AIA learning units and 5 California ZNCD credits. So without apologies, let's begin. Let's turn the calendar back to 2018, the year of your chapter's first symposium on climate change. I was researching Thwart Climate Change Now at the time, my book about embodied carbon. That December, as one of COATE's 10,000 members, I received an email, a post to COATE's website. I remember it to this day. It began, "Happy holidays. This is big." It explained that amid sobering projections about climate change, there was some upbeat news to share. Our hard work is having a big impact, it said. Our hard work caught my attention. Energy efficiency and power sector decarbonization, it said, have reduced U.S. building sector CO2 emissions by 20.2% below 2005 levels. This was despite adding approximately 30 billion square feet to our building stock. At first glance, I thought, wow, our work is having a big impact. Sustainable design must be working. But reading further, I realized this upbeat news, based on Energy Information Administration report, was attributed primarily to energy efficiency and also to power sector decarbonization. So what part of that was due to our work of designing buildings? Parsing the data, the minutia, was like opening Pandora's box. The 20% reduction was real, but it had little to do with building design. The significant reductions came from replacing coal with natural gas, wind, and solar, and a notable reduction in the energy used for illumination, from compact fluorescent lighting, from the introduction of LEDs, which perhaps was the most significant contribution to lowering operating emissions since 2000. But there were other factors too. Energy demand had decreased due to mild weather and to poor economic conditions. One might say emissions declined in spite of the design of new buildings. But there's something else to note here. EIA's building sector only included emissions from the residential and commercial use sectors, and only their operating emissions, such as heating, lighting, air conditioning, and electricity consumption, not embodied emissions, which we are here to talk about today. Not from manufacturing the construction materials, nor the fittings, fixtures, and furnishings, nor manufacturing the building systems or appliances, nor from the transportation of any of these items, nor manufacturing the construction equipment or vehicles or operating them. In other words, due to how economic sectors were categorized, the magnitude of emissions attributed to buildings was significantly higher than reported. This is what I mean by taking stock of reality, the veracity of the claims, and the efficacy of our actions. Since 2018, our understanding of sustainable design has changed. We've learned that not all carbon emissions have the same impact on the rate of global warming, that upfront embodied emissions associated with the production of construction materials accelerate global warming, They add fuel to the fire and play a defining role. Embodied carbon is the elephant in the room. Your first symposium on climate change that year addressed the global awareness of climate change and a commitment to act. It was promoted with the following statement, quote, "We cannot rely on public policy mandates in the United States to drive the important changes needed in creating the built environment. Los Angeles needs to take action." How prescient. Since then, we have built over 9.5 million privately owned housing units in the United States, 700,000 units in California alone. Last year, about 1.5 million new building permits were issued just for privately owned residential. Here we are 6 years later, 2024. We are still fed green platitudes and pats on the back. We rely on regurgitated statements based on a paucity of verified information. 6 years later, we are still talking about policy, about data collection, and mandates, not action. But action is possible by everyone in this room. According to the hidden climate impact of residential construction, a recent report by RMI, cradle-to-gate embodied emissions from new home construction could exceed 50 million tons of CO2 equivalent gases annually. This is just for U.S. residential construction. According to the study, up to half of those embodied emissions can be eliminated with commercially available, affordable, and code-compliant building materials. As much as 75% reductions are possible with one-to-one material substitutions. Reductions like this are available in all phases of construction, and all of it starts with an architectural design. The power to reduce those embodied emissions resides with all of you. It simply requires your sensitivity to embodied emissions plus some creative thinking, and that's what all of you do. In other words, relating spatial, structural, and envelope design to material selection while cognizant of embodied carbon. The same is true for fittings, fixtures, and furnishings. We need to think about sustainable design as commencing with low-carbon construction, which today's sessions will address. Some of you might ask, with wind and solar and electrification on the rise, why this sudden emphasis on embodied emissions? To answer that question, let's cut to the chase, connect a few dots. Let's look at carbon dioxide and the warming timeline. The blue line here traces the increasing concentration of atmospheric carbon dioxide in parts per million, ppm, from pre-industrial through 2023. In 1910, for the first time in over 300,000 years, the concentration of atmospheric carbon exceeded 300 parts per million. Last month, a new daily record was reached, 428 parts per million on March 15th, an increase of 120 parts per million over 113 years. The rate of increase since March 2000 is double that, 58 parts per million in only 24 years, 53% higher than the prior 24 years. We may actually hit a new record again this month. Unfortunately, atmospheric carbon is the factor that induces global warming. For the 2,000 years prior to 1900, the average global temperature stayed within plus or minus 1/4 of a degree Celsius. Since the early 1900s, it has increased more than 1.3 degrees Celsius. That's the red line on this chart. Notice the sharp rise since 1970. According to NOAA, the National Oceanic and Atmospheric Administration, 2023 was the warmest year since global records began in 1850. The average global surface temperature for 2023 was 1.35 degrees Celsius above the pre-industrial average, the Paris Agreement baseline. But the average for the month of September was even higher, 1.8 C above pre-industrial. The Arctic was 2.7. These increases were driven by the increasing concentration of atmospheric carbon dioxide. Temperature increases are nearly linear now with the increase in atmospheric carbon. The concentration of atmospheric carbon is driven by carbon dioxide emissions released from fossil fuels and industrial production. That's the black line on this graph, in billions of metric tons per year, gigatons. Every ton of CO2 emissions adds to global warming. The red circle here reveals the reduction in annual emissions in 2020 due to the COVID shutdown. The dip in the black graph is considerable, a reduction of more than 2 billion tons of carbon emissions for the year. But notice the blue line, the level of atmospheric CO2. It continues to climb. Why? Because CO2 emissions remain in the atmosphere. They are not reduced as emissions decrease. New emissions are additive. They will remain in the atmosphere for centuries. To flatten the growth of atmospheric carbon, we must reduce emissions now, annually. Unfortunately, as you can see from this graph, annual emissions have already returned to their pre-COVID level and continue to increase. And unfortunately, though we are well on the way to decarbonize our energy supply, demand for energy is also increasing. Worldwide, increasing faster than decarbonization, with no net gain. This drill on climate science is to make a single point: the urgency of tackling upfront emissions. What we spew into the atmosphere today and tomorrow will increase global warming immediately. This is why upfront embodied emissions are so egregious. Waiting for the 2030s or for future decarbonization to start flattening the curve is wishful thinking. Regardless of all the green certifications, fawning articles in the press, and competition award winners, we are not doing enough. It comes down to efficacy, the effectiveness of our attempts to design sustainably. Excess embodied emissions are not a necessary fact of life. They are designed in by structural, material, and aesthetic decisions, some even in the name of sustainability. To provide a little context for today's symposium, let's focus on a few building designs, ones that highlight what I'm talking about: embodied carbon, the upfront kind. This is the new design studio at the University of Miami's School of Architecture, completed in 2018 and LEED certified. The 20,000 square foot roof with its 5,000 square foot overhang was constructed from reinforced concrete. Actually, a nice trick. Embodied emissions estimate at more than 100 metric tons of CO2 in addition to those from the building's concrete walls. We all know that cement is responsible for approximately 8% of the world's energy-related CO2 emissions. I hope architecture students learn that as well. It's not that cement concrete was used, but rather the overabundance, the quantity. What were they thinking? Should this be a model for architecture students to emulate? This 62 residential high-rise in Miami was completed in 2019. The exoskeleton was clad with 4,800 precast glass fiber reinforced concrete panels, weighing a ton or more each. They were shipped from Dubai. 9,000 nautical miles in dozens of trips. CO2 emissions from concrete cladding might be deemed excessive by itself, but shipping from Dubai to Miami, emitting hundreds of thousands of kilograms of additional CO2 emissions. On top of that, they were shipped with custom steel cradles for protection, adding significantly to that embodied carbon. What were they thinking? This beautifully conceived lead silver project with geothermal wells for heating and cooling was completed in Connecticut in 2015. They chose environmentally sustainable glulam beams for part of the structure, a great carbon sequestering choice. The LEED certification for building design and construction noted the use of green building materials. Perhaps their point of origin was not part of the equation. The glulam beams were fabricated in Vancouver, British Columbia. The project is in Connecticut. Some as long as 95 feet were unsuitable for transport on winding roads. They had to be trucked by a route around the Rockies, from British Columbia almost to Mexico, then up and across the US to Connecticut. Around 20 truckloads, responsible perhaps for 250,000 kilograms of CO2 emissions. Even environmentally conscious design can be undone by transportation. Oh, I forgot to mention the full-height glass panels. They were manufactured in Germany, then shipped to Spain to be curved, and then, of course, here. Sustainable design, what were they thinking? This computer science building at Cornell University, my alma mater, was finished in 2014. A glass-clad structure with steel sunscreen appendages to block heat-inducing sunlight. This is the north side of the building. According to Cornell's sustainability officer, these angular sunshades contributed to the structure's LEED Gold certification. Nonetheless, intense sunlight from the east and south necessitated additional interior pull-down screens to screen the exterior screens. That's the photo on the right. Why one would design a computer lab with floor-to-ceiling windows that emit the sun in glare, I will leave that up to all of you. But it's hard to ignore the addition of steel sunscreens on the north side of a building in the northern hemisphere. Steel emissions are in the same league as concrete, responsible for about 8% of global energy-related emissions. Was this just for aesthetics? In the name of sustainable design? What were they thinking? For all of these projects and numerous more like them, the answer is simple. They were thinking about fluidity of the design. In some cases, perhaps sustainable design. You know, the thermal mass of concrete, the carbon sequestering wood construction, and the benefit of sunscreens. But they weren't thinking about embodied carbon, about the upfront emissions. So let's borrow a phrase from our Department of Homeland Security. If you see something, say something, as early in the design process as possible, before it gets baked in. When we have embodied emissions in mind, addressing excess materials and port choices and transportation emissions becomes obvious, and that's a good place to start. So let's focus now on you, the professionals who design and construct our buildings and infrastructure. Throughout the day, discussions will address low-carbon materials and strategies that enable your projects to minimize embodied carbon. Please keep in mind that at every stage of design, we need to question the global warming potential. From conceptual to structural to envelope design to fittings and fixtures through material procurement. Whether it's material selection or substitution, structural strategies, circularity or reuse, or material conservation. Your ability to predict the efficacy of your designs will rely on a few simple factors. First and foremost, how much of the product will you use? Second, what is the product's global warming potential, its GWP, its CO2 equivalent emissions per unit of use? And third, as we have already seen, where is it manufactured? GWP and point of manufacture can be found on a product's environmental product declaration, its EPD, if it has one. Which brings us to the Achilles heel of low-carbon design, EPDs. Addressing material abundance or the use of long-distance shipping is obvious. But trying to compare the emissions from one design scheme to another, or comparing one vendor's products to another, is something else. How many of you have actually used EPDs? Show of hands. Whoa, I didn't expect that. Okay. Well, I hope I don't upset you for what I'm about to say. If you tried but couldn't find many, you're in the majority. If you hope to qualify a project for IRA funding, or for Buy Clean California, or other Buy Clean programs, you must rely on construction material EPDs that qualify to the program standards. To evaluate the global warming potential of any manufacturer's products for any of your projects, you must rely on its EPD. Unfortunately, the availability, reliability, and comparability of EPD data is severely lacking. Aside from ready-mix concrete, there is a paucity of EPDs to survey and a little geographic distribution. For those that exist, there lacks a single rule set to support comparisons and certainty. EPDs must conform to product category rules, PCR. But multiple PCRs may be issued for a given product category by different groups of interested parties. And optional formats may be allowed by a single PCR. Here's an example. These are sections from 2 EPDs for ready-mix concrete from 2 California facilities of the same supplier, from page 2 of their respective EPDs. Both EPDs for mixes with a compression strength of 4,000 PSI at 28 days. They're both created from the same PCR and the same EPD program operator and the same third-party verifier, 5.5 weeks apart, last fall. And they were updated in Building Transparency's database this February, and they're part of the data that's used by GSA and whatever. Yet they differ in their disclosure certainty. And one comes with a huge caveat. The one on the left was computed using manufacturer-specific cement data, which is required for IRA projects. The one on the right used industry average data provided by the Portland Concrete Association. This is the one on the right. The GWP value declared on page 1 was modified by the caveat disclaimer on page 2. It states that manufacturer-specific cement impacts could result in variation of as much as 44%. Well, but why bother even looking at the EPD? I mean, in other words, the GWP declared the 270 kilograms per of CO2 equivalent might be inaccurate by 44%. A caveat like this renders an EPD meaningless. Fortunately, with recent scrutiny of Buy Clean programs, more EPDs now use manufacturer-specific values, but not a lot. But keep in mind, nothing requires EPDs to be comparable from manufacturer to manufacturer, or even from different plants of a single supplier, such as these 2. The EPA is working to change that by developing a registry for low-carbon construction materials that meet IRA standards. In addition, they are expected to release $100 million in grants this year to make it easier for manufacturers to issue EPDs and to make them accessible online. Hopefully, these programs will be viable, but they will take years to facilitate and gain traction. So what can you do in the meantime to cut upfront emissions until a sufficient supply of standardized EPDs is widely available? With time of the essence, how does one attack this problem? The answer is by focusing on what you can control. There are 3 phases to the accrual of embodied emissions in a product's life cycle. The first phase, from raw materials to installation, is known as the A block. Then comes the use period, the B block, maintenance, repair, and replacement, etc. Finally, the C block, end-of-life emissions, deconstruction, transport, waste processing, and disposal. If circularity is part of the discussion, there is a 4th phase, the D block, recovery and reuse. All of these are important. But our immediate goal is to reduce upfront emissions. That's the A block. What occurs past the A block, past installation, is speculative. More speculative the further out you go. Speculative about use, maintenance, repair, and replacement, especially about a building's lifetime, or whether components will be recycled or reused, or whether embodied carbon will even matter then, 40 years from now, should zero carbon energy dominate the grid. To some extent, I hope I don't upset too many people here, full life cycle modeling may be spinning wheels, at least for now. Life cycle A block emissions are tangible, controlled in real time by your decisions and your design and procurement decisions. So focus on your A block decision making. What about circularity, the potential for reuse? Am I saying don't bother? Absolutely not. Circularity is extremely important for many reasons, even if a particular component is never reused. Designing for ease of disassembly or reprocessing is a carbon benefit, and it may be designed to minimize waste, pollution, and landfill, all environmentally beneficial. Nonetheless, having low upfront emissions is critical for circular products too. Modeling is crucial to sound decision-making, from structure and envelope to environmental control systems and a host of other parameters. So how do we handle the EPD problem? Modeling and detailing are at different ends of the spectrum. That's if you model to design rather than model what you've already built. Industry or manufacturer average EPDs or database averages are sufficient for modeling design schema comparisons, whether for the structure, envelope, or interior. A GWP estimate for modeling can be determined from most EPDs, even those which may seem somewhat misleading. Just be sure to factor in the caveats. Comparing design approaches can be accomplished with generic information, but detailing is another matter. Ultimately, success or failure of a low-carbon project will be cast by the structural and aesthetic decisions carried out through detailing and locked in by a spec writer. And that's when emissions comparisons become critical, ultimately relying on the veracity of specific EPDs. Until we have a sufficient supply of EPDs and widespread comparability, low-carbon design will rely on your creativity and your skill sets, your design and material choices. So I will close with a few rules of thumb that I hope can help. Rule number 1 is the easiest way to cut carbon emissions. It's a throwback to Mies. Less is more. No matter what material you select, less of it is more climate friendly. Embodied emissions come by the pound or kilogram or by the unit or square foot. For example, a 50-pound bag of cement emitted about 40 to 45 pounds of carbon dioxide during production, almost 1 for 1. Of course, material reuse or circularity or increasing a building's lifespan by renovation or adaptive reuse serves this credo as well. Rule number 2, be cautious with products processed at high temperature. Firing ceramic, porcelain, and brick, sometimes multiple times for surface effects to create color or a shade of black or for glazing, adds emissions. Thanks to this helpful disclosure from a brickmaker's EPD, one can see the emissions impact of an aesthetic choice. There is a 21% spread in upfront embodied emissions from color group 1 through 10 that you can see here on the CPD. Your choices matter. Rule of thumb number 3, check out a product's material content. You can't tell a book by its cover. Many construction products are composites of materials, such as for roofing and siding. The principle of mass applies here too, the mass of the high GWP constituents. And of course, whatever the product, let's not forget transportation emissions to the construction site. But if you can only handle one of the above, make it rule number 1, use less. I came across an excellent report published by the World Business Council for Sustainable Development that might be of help as well. Net zero buildings halving construction emissions today. This report provides excellent strategies to reduce embodied carbon. It's available for free download at wbcsd.org. I highly recommend it. For a more complete picture of the mindset we need going forward and how our love affair with all things green and sustainable got us here, my book might help. Thwart Climate Change Now, Reducing Embodied Carbon Brick by Brick. I wrote it to be a solutions-oriented eye-opener. At COP28 in November, UN Secretary General Antonio Guterres noted, "It's minutes to midnight for the 1.5 degree limit, but it's not too late." Your first climate symposium got it right. It is we who need to take action. It comes down to our creativity and to our personal design decisions. With approximately 120,000 registered architects in the US alone, about 3.2 million estimated worldwide, we make a huge difference. Well, it can make a huge difference. And that doesn't include interns or other design professionals and the rest of the AEC industry. That is an enormous amount of specification power, capable of minimizing upfront embodied emissions through low-carbon construction. Keep in mind that embodied emissions from construction materials are released years before a building is occupied, years before infrastructure is ever used. That is why your ability to cut upfront emissions through design and by material selection matters so much, why it is so important. So let's get to work, and also let's spread the word. And please don't forget, if you see something, say something. Thank you for listening. Okay, so we have some time, I'm surprised, but we'll take any questions.
Thank you, Bill. I'm Rob Kay with Arup. Thank you very much. I really enjoyed that. How do you see the architectural community helping to leverage the other blocks down the life cycle of buildings from an architectural perspective?
What do you mean by the other blocks?
Well, as in maintenance, operation, deconstruction, the full life cycle.
Okay. Well, in the end, it's going to affect full life cycle. But the bottom line is that we got to be able to get there before we hit 2C. So, you know, it's really, my whole focus is we need an upswell, grassroots movement. Policy is not going to do it. And the grassroots happens to be all of you in this case. You know, and once it starts, you know, there's been no discussion of this. And, even, it's in the IRA, but very few people even know that, or even Buy Clean California, but policy just takes too long. So, I'm here for one reason only, and that is to spread the word that it's in our hands. And it's not only this, but once this happens, it's got to spread to consumer action as well, because it's all products, whether it's cars or, even you take the charging stations for, for electric cars. Well, what's discounted is the fact that there's embodied carbon that's going to be, to make the charging stations. That's been taken for granted, and we have to do that. So we need to do that. But the one thing that can be done now is design of new buildings and infrastructure, or make infrastructure less. Using concrete as an aesthetic element, it's very chic, but it's not helping. So that's where I'm coming from.
We have a question here.
Yeah, there's one.
Hi. You showed a few buildings that you mentioned not to perhaps replicate. Can you give an example of your favorite net zero carbon building?
I'm not going there. No, the bottom line is, look, is it your fault? No. We were brought up in architecture school and in our own and your practices or whatever with sustainable design and green. Okay, and so what did that mean? And I don't want to knock LEED. LEED is very important. It's educated an enormous number of people. But you can have a LEED Platinum building and have black smoke coming out of it, and that can be, there's no negative points. So, here we are. We got here. It's happening faster than anybody thought. And what can we do now? The only thing we can do now is cut embodied emissions, because it's all by choice. Okay, and so it's out there. We need to spread the word. I have to tell you that I have written numerous op-ed pieces to the New York Times, to LA, to Wall Street Journal. Nobody will pick this story up. It's got to get out there. So that's why we need to spread the word, and it'll have an immediate impact. The fact that COVID shutdown cut 2 billion tons, 2 gigatons in 1 year, is the proof of the pudding. The same thing happened in 2008 when the economy went down. If you look at the emissions from the United States in construction materials, way down because housing went down. But no, we have to build housing, but you have a choice how you build it.
I guess I'm wondering, and I appreciate the presentation and thinking about what natural materials are available locally. We're trying to do something super holistic here on planet Earth to regenerate and restore. And I think we're kind of stuck in this kind of insurance world of what's durable and resilient, those pieces. I guess going back to natural methods of building locally, craftsmanship, do you see that as the solution as well?
Oh, of course, it's all part of it. So, we certainly overbuild, but we're design oriented, and that's what the industry is. But again, if you buy glue, you can't do better than wood. It's sequestering the carbon, okay? But why did you, so cut the beams in half so you can buy them in the Northeast. The fact, I normally never critique a building that I haven't seen myself. The only one was the one in Miami that I haven't been. But I just, a month ago, before I put it in here, went up to Grace Farms to see that beautiful building, which was fantastic with the glulam beams and construction. But I went there because I wanted to talk to them and see for myself. And there was absolutely no reason. There's no reason that you had to have a 95-foot span. The fact is they had so many things hanging from these spans for the lighting and everything else. Aesthetically, it wouldn't have made a difference. So they could have gone with shorter beams coming from the Northeast. But whatever, it's a long process. I'm going to just want to discuss some of this at a lunch table. Part of the problem is it's a very long distance from design, conception, and strategies and schematics to the process of having a spec writer write something that's going to go out for bidding. Okay, so you can design, well, yes, you can make structural design things, but when you get down to the end, how do you control the process or get it down to the procurement level? And that is really where the problem is. But that's why this message needs to get out. It needs to get out in the press. It needs to get out in the AIA and the national. We can do it.
Bill, we have time for one more question.
Okay.
Excellent provocation. I really enjoy listening to your lecture. But I have a question. As an architect and researcher from the Global South, I research material extraction in Brazil, and I really enjoy when you said that we should focus on the A block decision making, but I was curious because I would say in countries from the Global South, policy would be something that I see as the only solution, or not even solution, like strategy to try to minimize impact. But it's interesting when you talk more about how it's in our hands as decision makers, but I see it's just I feel like a contrast when you look at territories and globally where extraction is happening. So I kind of wonder if it's about the ethics of us as designers, or how exactly we control or do due diligence in the Global South and in countries where policy and corruption might be also an issue in extraction and industrial.
Okay, I mean, that's a good question.
Impacting construction. Thank you.
It's a good question, and the whole social justice question is a good one. And I address this in my book. We have to do all of these things, but the bottom line is, when we're focusing on carbon emissions, I'm not suggesting that there be social inequality, but the bottom line is, your job is to design buildings, and we have to cut embodied carbon. There's a section in my book talking about, California trying to save water by encouraging replacement of toilets, and the embodied carbon to replace a toilet is just enormous. When a lot of toilets didn't need to be replaced, you could put a bottle of water in the tank to reduce the thing. And so, in the Global South, certainly the whole extraction process is extremely important, and that's all part of this. But we got to get our heads together, and we got to do both, but they're separate animals here, at least in my mind. In the A block, is where it's at, and the problem is that you look into Buy Clean California or IRA, and every one of these Buy Clean programs, every single one of them, they start out with talking about the whole life cycle. Well, you guys can't do the whole life cycle. You got enough trouble doing what you're doing. And why are you doing the whole life cycle when it's the front that we got to deal with? But then, in the legislation, it doesn't require whole life cycle. They're just looking at actually not even the whole A block, not even installation. Okay, so none of it makes sense. And there are political issues here, and how do you get it done? So that's why I say it's up to us to do it and to get the word out. So I appreciate your question, but we have to do both. Okay, thank you.
Okay. Thank you very much, Bill.